So, there's just really one thing that we want to talk about today, but it's pretty involved, all right? So you're going to need to pay close attention. The first thing I want to tell you about is there are two types of functions, okay? Two types of functions. There are even functions and there are odd functions, all right? In order for something to be an even function, the degree of the function is even. Now, when I say degree, what does that mean? His which exponent? Highest exponent, okay? The degree is even. Then, of course, we're going to call it an even function. If the degree is odd, we're going to call it an odd function. Okay? So those are the two types of functions we're going to talk about. That pretty much covers every kind of polynomial function, right? I mean, it's either even or it's odd. And you have studied both of them. You just never thought about it being this way. Okay? So, the first one I want to talk about is, let's talk about an odd function. Okay? Let's talk about an odd function. Now, if you said, whoa, that guy's odd, what does that really mean?
They're strange. Weird.
They're what? That's all it means, guys. They're weird, they're strange. Why are they weird or strange? Because they're different from you. That's the only thing, guys. Okay? So, listen. Odd just means different. Okay? So, an odd function begins and ends, begins and ends in what kind of directions? What did we just say it meant? Different. In different directions. They begin and ends in different directions. So, if it starts down, it ends. If it starts up, it ends. That's it, people. That's odd. It's different. Okay? Now, what if the leading coefficient, now what's a leading coefficient?
So the coefficient of the one is the highest.
Very good. The coefficient of the highest exponent. If my leading coefficient is positive, what's it going to look like compared to if my leading coefficient is negative? All right. So I'm going to draw some pictures, and I'm going to tell you what it's going to look like. And then we're going to talk about how to describe the pictures. Okay, so if my leading coefficient is positive, y'all, the sign of the leading coefficient tells you where your function ends up going. Okay? A positive leading coefficient is going to tell me that my function is going to end up going up. So if it's odd, where's it going to start? Down. So he's going to look something like this. Okay? Now look. Is he odd?
Oh,
Yeah. He begins and ends in different directions. Okay? Is his leading coefficient positive? Yes, because he ends up going up. Okay? You see how that makes sense? All right. Now, let's talk about this. Okay, well, let's talk about end behavior. That's what they call it, okay? End behavior. Now, we read from what?
Left to right.
Left to right. So how many ends does this graph have? Two. The left end and the right end. But we call it right hand behavior and left hand behavior. Okay? That makes sense, right? So, obviously, this is my right hand behavior, and this is the left hand behavior. Now, this is the easy way to do it, okay? You can only use one of two words. You can use rises or falls, okay? So, right hand behavior, guys, does it rise or does it fall? Yeah, it rises. It's going up. Left hand behavior falls. Very good. Okay, now the next way that we're going to write it, this is the one that always messes kids up. Okay? So, first of all, you need to know a few things. If I say f of x, what does f of x really mean? Y. That's all it is. F of x means y. Okay, now which way do y's go? Up and down, right? Everybody agree with that? So when I say f of x, I'm either talking about it going up or going down. Okay? X's. Which way do x's go? Left or right? Okay? On the right, what are x's approaching? Positive infinity. On the left, what are x's approaching? Negative infinity. Okay? Now, this is the symbol. It's an arrow. This is the symbol for approaches. That's what it means. Okay? I'll say approaches, but I'll write that symbol down. Okay, so see if you can answer my question. I'm on the right-hand side of this function. F of x approaches, what's f of x approaching? Positive infinity. Why? Because he's doing what? Yeah, he's going up, guys. As x approaches, you're on the right-hand side, so what's x approaching? Positive infinity. Okay, let's do this one over here. I'm over here on the left, okay? F of x approaches, what's y approaching, guys? Negative infinity. As x approaches what? Negative infinity. All right, so we did these, all right, and then the first class said, we started on the other one over here. And then one of the kids said, well, you know, Miss Davis, I think I got everything, but I don't know what that AS means. I said, that's the word as. And they go, oh, I thought that stood for something. And I said, no, it's just the word as. F of x, y goes up as x goes to the right. That's what that says. Y goes down as x goes to the left. Okay? All right, let's look at this one over here. This one, my leading coefficient's negative, so I know he's going to end up going where? Down. Since he's odd, he has to start up. So, now how do I know he's odd? Yeah, he begins and ends in two different directions, guys. He has to be odd. How do I know his leading coefficient's negative? Because he ends up going down, right? So let's see if we can do all these little things. Right-hand behavior. What is my right-hand behavior? False. Left-hand behavior. What is it?
I keep writing right hand and then writing behavior.
Yeah, I did that.
Oh, you can do that. It's okay. I mean, that's what you're talking about. So this one rises, right? Now, let's do it the hard way, okay? So, over here on the right-hand side, f of x approaches, what is f of, that's y, guys. What's y approaching? Negative infinity. As x approaches, you're on the right, yep, so it has to be positive infinity. The right-hand side of x is the positive infinity. Left hand. What's f of x approaching? As x approaches, perfect. Alright, now that kind of makes sense, right? That kind of makes sense. Now let's think about an odd function that we've been talking about, you've been talking about, you've been taught about since you were in, I'm going to say 7th or 8th grade, okay? What about a linear function? Is that an odd function? Yeah, that's an x to the first, isn't it? Okay? Doesn't he always begin and end in different directions? I mean, look, here's a line. Is this line's leading coefficient positive or negative? Huh? Positive. His slope is positive. Look what he's doing. He's going up, guys. Okay? What about this line? He's negative. He's going down. See, you've been talking about him. You just never really thought about him like that. It's true for every odd function. It doesn't matter if it's an x to the first, an x to the third, an x to the fifth, an x to the seventh. Doesn't make any difference. If he's an odd function, okay, he begins and ends in different directions, and the sign of his leading coefficient tells his right-hand behavior, what he ends up doing at the end. All right, so now all we got to talk about is even functions. Now, look, if an odd function begins and ends in different directions, what do you think an even function's going to do? Yeah, he begins and ends in the same direction. Okay, so again, we're going to have a leading coefficient. That's either positive or a leading coefficient that's negative. We'll draw us a couple of pictures. Now, ever seen anything like this? Oh, please, the dreaded chapter 4, right? A quadratic, an x squared. That's an even function. Does he begin and end in the same direction? Okay, he's positive. He had to end up, and because he's even, he had to begin up. Okay, so let's write down all of his stuff. What about his right hand behavior? What does his right hand behavior do? What about his left hand behavior? Very good. Okay, so now let's write the hard one. F of x approaches positive infinity. Y'all, it's going up over here. That's positive infinity. As x approaches, what does x approach on the right? Very good. Now we'll go over here to left-hand behavior. F of x is my y, so where are the y's going? F of x approaches positive infinity. They're going up again. As x approaches, on the left it's negative. Very good. Okay? Now, what about this one?
Are there ever any graphs that we'll have to remember like that?
Yes, of course. Why would you have some if you didn't never work with them? Yeah. I like the way y'all aren't going berserko like the other kids did, though. Yeah, they went berserk because I put a bunch of humps in there. Like, what? People, we're not even talking about the humps right now. We're just talking about in behavior. Okay, so, uh-oh, not a B. Right hand behavior. Very good. Right hand behavior falls. What about the left hand behavior? He falls too. Now let's put it the difficult way. Okay? Now listen, this is what it's going to ask you on the test. Okay? It's going to do this. It's going to start you out and say f of x approaches as x approaches. Okay? He's asking you to do this. And then the next one, it's not going to say it because it's wanting you to follow this lead. All right? On this right-hand side, what is f of x approaching? As x approaches, very good. Now, I want you to write the same thing over here, but make it appropriate. So f of x approaches as x approaches, perfect. Okay? Now that's not hard, is it? All right. So what kind of things could we do with that? Well, one thing I could do is I could draw you a picture and you could tell me about the function, right? Okay? Watch this. Let's talk about this function right here. First of all, tell me what you know about him.
He's odd.
Yeah, he's odd, guys. He's going in different directions, okay? So he's odd.
He's also negative.
What's negative?
Reliable.
His leading coefficient is negative, okay? What about
Even.
all right?
Leading coefficient positive.
Now, what if I went back up to this one right here and I just wanted to play with him a little bit? Could you tell me he is at the very least a what degreed polynomial? Think about a third, because we've drawn some third ones, okay? Do you think he's more than a third?
Fifth degree.
Okay, now a lot of you are saying fourth. People, look what you said he was. You said he was odd, so can he be a fourth degree? No. So he is at least a what?
Fifth.
He's at least a fifth degree. Okay? He's at least a fifth degree. Now, use that, all right? I told you which one. I told you Spencer was right. Now, look at this one. Now, look, people. He's even, so don't be picking numbers like 3, 5s, and 7s, all right? So, he is at least a what?
Fourth degree.
Very good. Now, how are we getting those? How are y'all getting them?
I'm taking the number of minimums and maximums and adding 1 to it.
Okay, so Spencer's counting the humps, huh? I mean, he said it in a fancy way, right? But I mean, that's what he's doing. He's counting the humps. 1, 2, 3, 4 humps, and he's adding 1, so it has to be at least a fifth degree equation. Now that makes sense, right? Because here's a quadratic. How many humps does it have?
1.
And you know it's a second degree, okay? There's a line. How many humps does it have?
9. It's a first.
It's a first degree, okay?
And if it's just a dot, that's a 0th degree. But
Yeah, that's a point. Okay? All right, look at this one. How many humps does he have?
3.
3. 1, 2, 3. So he's a fourth degree. Someone else did this morning, okay? Someone else said this is the way they said it. I counted how many times it changed direction. Okay, watch this. 1, 2, 3, 4, 5. So he's at least a fifth degree. 1, 2, 3, 4. So he's at least a fourth degree. I say pick a way and do it that way. Don't be trying to go back and forth because they're totally different. All right? So pick a way that resonates with you and sticks in your brain and then do it that way. Now, when I say at least fifth degree, could this be a seventh degree equation?
yeah, just it could be, off the graph.
Okay, it could be off the graph. All right?
It could also be too small.
So here's what I want to ask you. I want to ask you that this is an x squared, right? Do you know what an x to the 10th looks like?
It has it has 5 minimums and 4 maximums going up.
Oh, that's what he was doing. I couldn't figure out why he kept drawing in the air. Okay, so he was counting minimums and maximums. Okay? It does look the same. Paige plugged it in her little calculator, and she said, what? It looks just like that. Okay, so it does look just like that, except this. This is what I tell my kids. He's older than this guy, right? I mean, he's only 2. He's to the 10th power, so he's a lot older. And I'm just going to tell you that the older that you get, the wider the bottom gets and the flatter it gets. Okay? So a little bit of an exaggeration, but the bigger you make this exponent, the wider it gets across here and the flatter it gets. Okay? So, what, Spencer? Why does this one not have those 9 humps we're looking for? What would we have to do to that to make it have all those humps?
We have to add the
Yeah, you got to put some fluff and stuff in there. You got to put some minus 2x to the 9th, plus 7x to the 8th, plus 3x to the... You see what I'm saying? You got to put some junk in there. That's what makes it have all those humps. If you don't put any junk in there, it looks just like a parabola, just a little bit flatter and wider across the bottom, the bigger you make the exponent. Okay? Everybody understand? All right, that's not too bad, is it? That's not hard to understand. Okay, I want to do one thing before we stop. I mean, my pen's disconnected.
One thing I hate about these calculators is that if you don't press over when you're doing an exponent, you say x to the 10th, and it just keeps going up until the exponent.
Yeah.
Do what now? Oh, yeah, you have to. You have to get
I
out of
look-
the
I
exponent.
look down like, what?
Yeah.
Going on?
You do. You got to pay attention to what you're typing in. I agree. I'm not used to that either. So, all right. So one thing I want to do before we stop, and then I'm just going to stop for a second. I just want to check you on something. I want to see if you can tell me what is the right-hand behavior of this function right here, and I want you to write it the difficult way. Okay? So you write it on your paper. Okay, and then I'll get you to tell it to me, and we'll see if you're right. What? I asked you to write it like we wrote it, the difficult way. Like f of x approaches what, guys? Negative infinity. As x approaches what? Okay, this one right here. F of x approaches as x approaches. Very good. Okay, so do y'all think that's terribly hard? Okay, kids struggle with that a lot. A lot, okay? So, y'all did good. Y'all did really good. All right, so I'm going to give you a little worksheet. It's going to have like 5 problems on it. Okay? I mean, it's going to have a whole bunch more than that. But we're just going to talk. We're just going to do 5 of them. Okay? We're just going to do 5 of them. Really? Because I don't feel well. I'm tired. And I'd like to take this porcupine quill. So like if I stuck it in my head would feel a lot better. It would just pop. But so I just want to make sure that you can do a problem like this, because this morning I just handed it out to the kids and they went berserk. I've never in my life, I was like going, what the heck are y'all doing? So I just want to talk for a second about this. Yes, Spencer? Through the ear? Oh, that seems very painful. I think even my eyes are swollen up. Ugh. Yeah, but wait, you have to wait and see what those kids did. Okay. All right. First of all, if this were a plus sign, what would I do? Just take the parentheses away and do all your stuff. It doesn't change anything. Okay. If it's a minus sign, what does it do? Yeah, it changes all the signs, not just the first one, guys. It changes all of them. So it becomes x to the 3rd plus 2x squared minus x minus 7. What does this become? Minus 4x to the 3rd. What does this become? Plus 3x squared minus 5x plus 1. Okay, and so then they start doing this. Tell me if it's right or wrong. like. I was going, what are you doing? And they go, well, we're doing this, so we have to add our exponents. I'm like, I'm pretty sure it's when you're multiplying, you add your exponents. I'm pretty sure if you have 1 x to the third and I take 4 x to the thirds away from you, you ain't got any x to the 6th, okay? You owe me 3 x to the third, okay? So don't be crazy. All you're doing is collecting like terms, okay? Not any big deal. All right.